Welcome to qnawire.
In this question, we have a small source of sound which has a frequency of 500 Hertz. It is rotated in a circle with a radius of 100 over pi centimeters at a constant angular speed of 5 revs per second, as shown here. The listener stands here next to the circle in the plane of the circle, and we want to find out what the minimum and the maximum frequencies observed are when this little speaker is at different points in its rotation. So I've labelled here the points B and the point A. So we've got these two expressions here for what the frequency will be, where Vs is the velocity of sound and Vm is the velocity of the little speaker. So first we need to calculate the velocity of the little speaker. We know that linear speed for angular motion is equal to omega r. We know omega and we know r, so plugging this in, we can say that it's equal to 5. And now remembering that r is in centimeters, we want to convert that to meters, so multiply by 10 to the minus 2. So 5 times 1 over pi gives us our linear velocity, which is simply 5 over pi, so 1.59 meters per second. So now that we've got this, we can work out the frequency at the point A and the point B from these two expressions. You can see in A, you simply subtract the velocity of the mass speaker from the velocity of sound, whereas in B, you add them up on the bottom. So starting with A, we can say that the frequency at A is equal to the speed of sound, which has been given as 332, over the speed of sound minus the speed of the speaker, so 332 minus 1.59, all multiplied by the initial frequency, which we know is 500 Hertz, so times 500, which is equal to 515 Hertz. Applying the same method for part B, we can say that at part B, the frequency is equal to, again, the speed of sound on the top of this fraction, over the speed of sound, however, this time adding the speed of the speaker, so plus 1.59, again multiplied by the frequency of the sound, so 500 Hertz, which gives us a frequency of 485 Hertz. So we can see that this is the furthest point away and this is the closest point to the observer. So we can say that the maximum frequency observed is 515 Hertz and the minimum frequency observed is 485 Hertz, and that occurs at the furthest part away from the observer.